Hello everyone. In this video, I will show you how to recover data from an SHR-2 or SHR Synology Hybrid RAID array on a Synology DS418play NAS in a Windows 11 environment. We will look at various data loss scenarios, including accidental deletion of files or folders, volume formatting, and storage structure corruption. You will learn what to do in case of NAS hardware failure or the failure of one or more drives, and how to access information if the RAID array becomes inaccessible and network folders no longer appear. Additionally, we will demonstrate a data recovery scenario from a virtual LUN created in DSM. This material will be useful for IT professionals and Synology NAS users who configure RAID arrays, manage LUNs and network directories, or use disk space for deploying virtual machines, server applications, and databases. The Synology DS418play is a network-attached storage device that provides centralized data storage, document and media sharing, and secure backups of important information. The device supports up to 4 hard drives in SHR, SHR-2, as well as classic RAID 0, 1, 5, 6, and 10 configurations, allowing for an optimal balance of performance, storage capacity, and data protection. Key features of the DS418play include 2 gigabit Ethernet ports for fast local network access, support for SMB/CIFS, AFP, NFS, and FTP protocols for compatibility with Windows, Mac OS, and Linux. ISCSI function for connecting to servers and virtual environments. Hardware-accelerated video transcoding and multimedia handling. Centralized data backup via Synology services. Management is performed through the intuitive Disk Station Manager web interface, which allows for drive, users, and service administration. The device ensures automatic backup and synchronization with remote servers, guaranteeing secure storage and access. To connect to the Synology DS418play in Windows 11, the NAS and the computer must be on the same local network. First, download and install the Synology Assistant utility on your computer. Once launched, the program will automatically scan the network and detect connected NAS devices. If your device doesn't appear, open the Preferences menu in the top right corner and enable Allow Compatibility with devices that do not support password encryption to find older or specific NAS models. After the scan is complete, select the desired NAS and click Connect. The program will open the DSM web interface, where you can manage storage, create or mount volumes, manage users, and configure ISCSI LUNs. If you already know the NAS IP address, you can connect directly by any browser by entering the address and logging in with your account. To create an SHR-2 array, open DSM, go to the main menu, and launch Storage Manager. This section has 3 main tabs: Overview, Storage, and HDD/SSD, where you can view the system status, pool/volume settings, and drive information. The Overview tab shows the NAS layout with installed drives, their current status, and detailed info like model, capacity, and health. The HDD/SSD tab provides advanced information, including smart parameters, temperature, event logs, and diagnostic tests. Before creating SHR-2, you must create a storage pool. Go to the Storage tab and click Create to launch the Storage Creation wizard. In the wizard, click Start, and in the next step, select the RAID type, SHR-2. Next, check the required drives in the Selected Drives field and specify the capacity to be used in the Allocate Volume Capacity parameter. Choose the file system and confirm the settings by clicking Apply. The system will begin creating the storage pool and volume. You can monitor the progress in the Storage Manager. Once the storage is set up, you can use it for data. To do this, create at least one shared folder. In the DSM homepage, open File Station. If no folders exist, the system will prompt you to launch the Shared Folder Creation Wizard. Enter the folder name, set up access permissions for users or groups, and click Finish. Now you can start writing data. To upload files, use the Upload tab, or simply drag folders from Windows directly into the shared folder. Once you have successfully created your network file storage, you can additionally create a LUN within an existing volume. In DSM-7, this is done through the SAN Manager section, which is available in the main menu. This is where you create and manage ISCSI LUNs, configure connection targets, and work with block storage. To create a new LUN, open SAN Manager from the main menu, go to the LUN tab, and click Create. In the window that appears, specify the LUN name, set its location, and set the size and space allocation type. You can also configure permissions for hosts and initiators that will be allowed to access the LUN. After confirming the settings, the system will create a new LUN ready for use. A target for the LUN is created automatically during this procedure. After creating a LUN in DSM, it must be connected in Windows 11 to appear as a separate logical drive in the system. iSCSI clients are used for this purpose. In this case, the connection will be established using the built-in Windows tool, iSCSI Initiator, which allows you to connect to the iSCSI target and mount the LUN for further data operations. In Windows 11, open Search and type iSCSI Initiator, then launch the utility. Once the program is open, go to the Discovery tab and click Discover Portal. In the window that appears, enter your NAS IP address, leave the default port, and click OK to confirm. After that, the target associated with the previously created LUN will automatically appear in the Targets tab. Select it and click Connect to establish the connection and make the LUN available in the system. Next, open the Disk Management utility to initialize the virtual LUN disk and create a partition on it. Once the setup is complete, the LUN will be displayed in Windows as a regular logical drive, and you will be able to write data to it. In the event of a hardware failure or firmware crash, if you cannot access the Synology DS418play directly or via the web interface, you can use Hetman RAID Recovery to recover your data. This is a specialized solution for working with hardware and software RAID arrays, supporting most common file systems and RAID levels. The program analyzes the array's service information, reads configuration parameters, evaluates the status of each disk, and reconstructs the RAID structure. After this, access to data is granted while maintaining the directory structure and file integrity, allowing for highly accurate information recovery. Before taking any action, be sure to record the exact sequence of disks in the RAID array. Each disk has its specific place in the data storage and parity calculation structure. Therefore, changing the connection order may cause file corruption and break the array configuration, significantly complicating the recovery process. To minimize the risk of data loss, it is recommended to document the location of each disk in advance and verify their connection correctness before starting the recovery procedure. To do this, connect the disks to your computer via SATA ports or use a docking station or an appropriate adapter. If it is physically impossible to connect all disks at once, an alternative option is to create a full image of the inaccessible drive and use it for further analysis and data recovery. Run Hetman RAID Recovery. At startup, the program will automatically detect all connected drives, analyze their status, and attempt to reconstruct the RAID configuration based on service information. The main window of the program will display the found disks and reconstructed arrays available for further scanning, structural analysis, and data recovery. Select your SHR array and run the fast scan mode. After the scan is complete, the contents of the RAID array available for recovery will be displayed in the program window. Mark the necessary files and folders and click the Recovery button in the top menu. In the next step, specify the destination for saving the recovered data and confirm the action by clicking Recovery. Once the copying process is finished, click Finish. After completing all recovery stages, the data from the RAID array will be available for use again. If you need to recover data from SHR-1, follow the same steps. In this case, we demonstrate a scenario where 2 disks in the array have failed, making automatic structure detection more difficult. Using RAID Constructor allows you to reconstruct the configuration manually and prepare the array for scanning and information recovery. In this type of NAS, SHR-2 is built so that the beginning of the file system is located at an offset relative to the beginning of the physical disk. In case of partial deletion of service information or metadata corruption, automatic detection of this offset might be impossible. To determine the correct offset value, use the hex editor. The analysis should be performed specifically for the physical disk or partition containing user data, not for the system volume. If the exact disk order in the RAID array is unknown, the process of finding the marker and determining the offset must be performed separately for each disk in the array. Launch the hex editor by right-clicking on the desired disk or by using the Ctrl-H shortcut. In the hex editor window, click the search icon, enter the search marker Label 1 for SHR and SHR-2 configurations, and click Find. The Label 1 value should be located at the beginning of a sector, indicating the start of the volume's data area. The offset parameter is defined as the sector immediately preceding the sector with label 1, and this sector must be filled with zeros. This video shows in detail how to correctly calculate the offset value and apply it during manual array reconstruction. To work in RAID Constructor mode, you need to know the basic parameters of your disk array: the RAID type, block order, block size, and bytes per sector set during the array creation. For SHR-2, the following values are used in most cases: block order, left synchronous, P plus Q; block size, 64 kilobytes; bytes per sector, 512. These parameters must be specified during the manual reconstruction of the array in RAID Constructor. After entering the required parameters, select the disks that make up your SHR array in the Available Disks field and move them to the Selected Disks field, following the correct sequence of their placement in the array. If the exact order of the disks in the array is unknown, it can be established through trial and error. Change the order of the drives in the Selected Disks field by moving them up or down with the arrows and refresh the reconstruction result each time. Double-click on the required disk or click Change Disk Offset/Size icon. In the window that opens, Enter the determined offset value in the Offset field, change the units from bytes to sectors, and click OK. The program will automatically convert this value into bytes. This parameter must be set for all real disks in the array, except for modeled empty disks. If one or more disks cannot be connected physically, use the Add Empty Disk function, which allows you to add a blank disk to emulate the missing drive. It is crucial to maintain the exact order of the disks in the array, as any violation may cause incorrect RAID reconstruction and make data recovery impossible. When finished, click the Add button in the bottom right corner to move the reconstructed array to the main program window for further scanning and data recovery. If a LUN has been deleted and you need to recover data, you can also use Hetman RAID Recovery. After the SHR-2 is correctly reconstructed in RAID Constructor and scanned, and the results appear on the main screen, you need to find the directory where the LUN is stored. The virtual disk is located in the System folder at ISCSI-TRG. This folder is displayed among the found data in the list of scanned partitions and contains the LUN file, which is available for further saving and recovery. To start recovering data from the LUN, you must first save it as a separate file. To do this, click Recovery, then select Next, choose the Save to Hard Disk option, and specify the folder to save the image file. Once the process is complete, an exact copy of the LUN will be created as a separate disk image. This file allows for further analysis and data recovery independently of the state of the original RAID array and without reconnecting the physical disks. Next, open the main window of the program and use the Mount Disk function. In the list of sources, select Raw Disk Images, click Next, and point to the saved LUN image file. After mounting, it will appear as a separate virtual disk. Perform a scan and recover the necessary files by saving them to another medium. Conclusion. Thus, in this video, we have demonstrated a practical and proven method for recovering data from SHR-2 and SHR arrays created on a Synology DS418play NAS. If this material was helpful to you, please support the video with a like and subscribe to the Hetman Software channel so you don't miss new publications. If you have any questions or need further clarification, feel free to leave them in the comments. We will provide detailed explanations on working with Synology DS418play, creating and recovering SHR and LUN, and show you how to perform data recovery quickly, safely, and correctly. Thank you for watching, and we hope your data always remains securely protected, regardless of the storage type.